Welcome to cubic functions. This is the last of the videos in the polynomial functions unit. So if you're finishing this up, you're ready for the test. Previously, we had looked at parabolas or quadratic functions. And so instead of x squared, we can see x squared, but we absolutely have to have an x to the power of 3. So where the highest exponent on the variable is a 3, that definitely means that we've got a cubic function here. You may or may not have any one of these or all of them, but this x to the power 3 is sort of required. When you do have that, you can get one of two forms. And these arrowheads are indicating that this is extending forever upwards and forever downwards. And so we don't see that vertex that we did with the parabola, that highest point or that lowest point. What we get is we get a relative maximum and we get a relative minimum. So on these, I'm going to just kind of put a little dot there. Here we'll have our relative max. And it's basically like a turning point. That's sort of what I think. And then this guy here, we'll label that as a relative minimum. And so what we want to do is, again, show those as x and y values. So let's call that 1, 2, 3. Oh, minus 3.5. And then up for y, 1, 2, 3, 4. Let's go with 5. So that'll be the coordinate point for the relative maximum. The relative minimum, let's label that as minus 1, 1. So the x value is minus 1, y value of 1. We can have x intercepts and y intercepts on our graph. So for the x intercept of this one, we see it here. Notice how in this case we only have one x-intercept, and in this case here we actually have 3 x-intercepts. So cubic functions can have either 1 or 3. This one we'll call minus 1, minus 2, minus 5, and then 0 for the y value. For a y-intercept, we've got one here. Let's call that 0 for x. That's a characteristic of the y-intercept. The x value always has to be 0. And let's just, because we called that 1, let's just call this a little bit higher than that, 1.2, because really it shouldn't be a 1, because if that's the relative minimum, that'll be the very lowest point of the turn. This needs to be a little bit higher up. For domain in cubic functions, we're looking for what value of x can be put into the function in order to create a number out. And every single value for x on this line is associated with a point somewhere on the function. So we're stuck again where x is in the set of all real numbers. The range... So what numbers come out of this function? Like, can we make really negative numbers, like negative 1,000,000? Could we make a positive 1,000,000 from this? And because these arrowheads are extending up and extending down, everything's possible. So y is in the set of all real numbers. Y could be really big or really small. And for end behavior, here we're talking about the quadrants. So if you remember from our previous videos, we have 1, 2, 3, and 4. So they're going counterclockwise. And we're going to scan from left to right. So we scan from left and we meet we meet the function down here in quadrant 3. And we leave the function in quadrant 1. So we would call this an end behavior of 3 to 1. And I ran out of room, but another characteristic is we should say whether this is increasing or decreasing. And we'd want to look here. As x gets bigger, what happens to y? As x increases, y increases, so it's going up. So we could call this an increasing function. So another form of the function could be looking like this. And this would be if, let's say, your a value was negative. If you had a negative coefficient out front, you'll end up looking like this. And so you're going to have a relative maximum, so sort of a high point on one of the hills. You'll have a relative minimum, a low point on one of the hills. In this case here, we have actually 3 X intercepts, and we have 1 Y intercept. So it's possible to have a single X intercept or 3. So let's start labeling these. The relative max for, let's call that 5 comma, that looks like it's about 3.5. It's kind of in the middle. The relative minimum, let's go with 1 for X value and down to 2.5, negative 2.5 for Y. The X intercepts, we're going to have 3, so we need 3 different points. So the commas, the brackets, everything's important. So let's start labeling these off. A negative 1 comma 0. This one will be 3 comma 0, and then that one will be 6. The y-intercept, I kind of put it here. So the y-intercept, the rule is that it definitely, the x value has to be 0. And let's go down to about maybe negative 1.8. It doesn't seem like it's all the way at 2 yet. For domain, what value of x can produce a y? All of them. If I put in a positive 10, I'm going to get an answer. If I put in negative 10, I'm going to get an answer. For range, so what answers could possibly come out, and every real number could possibly come out as an answer. We could get plus 1,000,000 or negative 1,000,000. And we could also get 0. That's kind of always a tricky one. Looking at our end behavior, so swiping from left to right, we're going to meet the function here in quadrant 2, and we're going to leave the function in quadrant 4. And then lastly, is this an increasing or decreasing cubic function? As x gets bigger, what happens to y? Y seems to be getting smaller. So it's getting more negative. So we'll call this decreasing. And I know a lot of you will they'll know that it's decreasing because it's going down. When it's down, it's decreasing. When it's going up, it's increasing. But, you know, the rationale behind it is as x gets bigger, y is getting smaller. So just one little note about the cubic functions and graphing. If you're working with MetaCalculator, they will not give you those relative maximum and minimums. But if you use Desmos, as you initially type in your function and press enter to graph it, it will show you those points, and you can kind of hover your mouse over and identify what those points are. So when you're trying to find out what is the relative max and min, I would suggest using Desmos instead of the MetaCalculator.